Okay, so good afternoon, everyone. Thanks for coming for this session. Lost in AI translation, turning buzzwords from hype to reality. First, a little bit about me. My name is Andre. I'm a lead infrastructure engineer here at Thoughtworks. I like music. I like playing music. I like sports, and I'm passionate about technology as a whole, and also passionate about demystifying complex topics. So that's why I give some talks here and there, and that's why I'm here. And also, it's good to point out that these are the only pictures on these presentations that were not generated by AI, and I mean it. Have you ever been in a meeting where AI terms were flying around, words like RAG, embeddings, vector databases, and so on, and you just find yourself kind of nodding along, hoping no one would call you on to explain what they actually mean? If so, I think you are in the right place. The world of AI moves incredibly fast, and this jargon can feel overwhelming. Like, especially for me, as an infrastructure engineer, I'm a very visual person, and when I'm learning a new topic or subject, I like to use analogies because it makes my learning easier, and that's why I came up with this talk. And my goal today is not to make you all AI experts. This takes lots of time, but instead is to give you a simple, powerful mental model to cut through the noise. And we are going to do that by using a single unified analogy: the world of music. So let's start with the biggest term of all, AI, or artificial intelligence. So think of AI as the entire universe of music. And just like music is a huge category, AI is a massive field of computer science. The next term that we have, ML, or machine learning, think of, instead of teaching musicians with rigid sheet music, we have them learn by listening and develop intuition. And this is the key difference in modern AI. ML is a subfield where systems learn from experience without being explicitly programmed. And here we are focusing on a special kind of musician that is called generative AI. This is kind of the composer who creates new melodies, not just plays old melodies. The composer don't just analyze, they create, right? And generative AI is a class of machine learning models that can create new music, for example, can create new and original content after learning, being trained from a massive training data set. So for the next 20 minutes or so, my goal is to give you a tour of it using this analogy of the world of music. So we'll meet the composer, understand their musical mind, see how they learn, look at the orchestra they conduct, so on and so forth. So how do we form our master musician? It all starts with their musical mind. So the foundation is something called neural network. Think of it as the musician's brain and the auditory system. So these models are built on a computational model of interconnected nodes or neurons, just like our human brain. And when our musician has a brain with many, many layers, we call it deep learning. So this simple means that our composer has a deep music intuition, allowing them to understand very complex harmonies and musical structures and so on. But where does the musician's talent actually live? In their music intuition. This is what we call parameters or weights of the model. A parameter is just a number that determines what the composer creates given an input. And you'll hear this a lot. Models with different parameter counts. For example, a new composer like Llama 3 from Meta comes in many different versions, from a version with 8 billion parameters all the way up to a version with 405 billion. Generally speaking, the more parameters a composer has, the better they perform. We often see that as models get bigger, they become more capable at specific complex tasks. Now, developing a world-class musical mind requires, of course, a place to practice. This is where the GPU comes in. GPU stands for Graphics Processing Unit. A GPU is like a high-performance recording studio or concert hall that allows for practice at a massive scale. It's the specialized hardware that lets the musician practice thousands of melodies at once and in an incredible fast pace. So once the mind is sharpened, we have our model, or LLM, large language model. This is the trained composer ready to create some music. An LLM is a versatile musician ready for almost any creative challenge. Note here that I said almost, not for all creative challenge. For example, in one moment you can say to an LLM, give me the main theme of the symphony, and it will. In the next moment you can ask it to compose a new verse for the song, and it will create a new one. You can even get more technical and deep and say, analyze all the harmonic progressions in this jazz solo, and the composer, LLM, can do that too. And of course, you've heard of GPT. What is GPT? GPT is just the name of a famous composer from a specific conservatory named OpenAI. It's a brand name, but it's also descriptive. GPT stands for Generative Pre-trained Transformer. So we have our composer, right? LLM. How do we train them? First, the music could be broken down into units the composer can understand. This is what we call tokenization. And the units are called tokens. A complex piece of music is split or divided into its fundamental building blocks, and each block gets assigned a number in the composer's mind. And it's not just single notes. A common chord might become its own token, or even a specific sequence of two notes that appears frequently. But in this case, the order is also critical because a chord C followed by a chord G is a different musical idea and a different set of tokens than a chord G followed by a C. So essentially, we are converting the rich language of music into a sequence of numbers that the composer's minds can process. And with these tokens, the main training begins. And we call this pre-training. This is where we use immense amounts of data and compute, like having our composer listen to all the music ever recorded in the world to create what we call a foundation model. Think of this as a composer who knows all of the music theory and can complete any musical phrase, but doesn't yet have a specific style. They are just a brilliant music completer. And then there's post-training, which is any training that happens after pre-training, of course. That's why we call it post-training. And this is how we take that technically perfect foundation model and turn it into something useful that we can use, right, to produce a new music. So post-training is how we shape the composer into a specific artist, like a jazz improviser or a pop artist, pop songwriter, and so on and so forth. So after pre-training, the composer is skilled, right? But might need a producer. In fact, in the world of music, all of the artists, they have a producer. This is where reinforcement learning comes in. The composer learns via trial and error, getting rewarded for good melodies they write. So a famous version of this is what we call reinforcement learning by human feedback, which uses, of course, human feedback to create those rewards. And this is important because it aligns the composer music, the music that the composer is creating, with what listeners actually enjoy, what they want to hear. And this is kind of how the original ChatGPT was trained to be helpful for us nowadays. Finally, sometimes you just need like a 3-minute hit song, not a 30-minute opera. So this we can call distillation. Think of a master composer known for complex albums, for example. Our teacher assigning an apprentice, a musical apprentice, with creating a catchy pop single, for example. The single takes the best melodic ideas from the larger work and packages them into something smaller and more focused. For example, a powerful composer like GPT-4o model from OpenAI was used to generate data to train a smaller, faster version called GPT-4o Mini. Okay, so our composer is trained, ready. How do they actually write a song? It all starts with their mental library. An embedding is how the composer organizes every musical idea she or he has. Think of it like a magical record store where albums are sorted by vibe, not alphabetically. So think of it like all the heavy metal is in one corner, all the calm folk music is in another corner. So similar ideas end up right next to each other. And to search this store, this magical record store, you need a great catalog. This is the vector database. So it's a collection of our musical ideas, their locations, their embeddings, often with metadata like genre or artist or music type, this kind of metadata. So this allows the composer to find music that is not just similar sounding, but also contextually relevant. So we ask for a new song, and the act of the composer actually writing the music is called inference. The key point here is that the composer creates the song one note at a time, predicting each new note based on the sequence that came before it. This is crucial because you are calling the composer for every single note, which is why it requires so much mental energy or compute cost. The quality of the song also depends heavily on our direction, and this is prompt engineering. It's the art of giving a clear creative brief, like, for example, write a song is a bad prompt. But if we write like write an upbeat pop song about a summer with a catchy chorus, this is a great prompt in order to create our music. But sometimes, like everything in life, things go wrong. Um, and then we have a hallucination. So hallucination, we can call like a creative error. It's when the composer writes notes that are impossible to play. And this happens because the model is a probability machine, not a truth machine. So how do we prevent these errors? How do we prevent our composer from hallucinating? That's when we use RAG, which stands for Retrieval Augmented Generation. Think of it this way. Instead of just asking our composer for a song, we first search our music library for relevant examples, kind of an inspiration playlist. We then give the composer our original request plus this playlist as a context. Technically, the user's query first retrieves information from a knowledge base, and this context is then used to augment the prompt, which is finally given to the LLM to generate the answer. This is a powerful way to ground the composer in reality rather than leaving them to their own imagination. And then we have chain of thought. It's like the composer humming the melody, like ta da 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 da, thinking step by step to ensure logic before writing the real music. So what's next for our composer here? So first, multimodal AI. This is a composer who also creates not only creates music, but also creates the album art, directs the music video. The next generation of AI that needs to understand multiple data types or modalities. So that's why we call multimodal AI. And the next is the talk of this year of 2025, AI agents. So everybody's talking about that. Think of an AI agent as an executive producer in our music analogy who manages resource to achieve a goal. This is called agentic AI because agency exists on a spectrum. For example, on one end, the agent uses tools we give it, like an inspiration playlist we've talked before. Further along the spectrum, we just give the producer a goal like produce a hit record for this summer for me, please. And then it decides which tools to use, like which studio to book, which musicians, like which guitarist to hire, which drummer to hire, and so on. But at the most extreme end, the agent might create its own tools. Like imagine an agent building an entire new recording studio just to get the job done. Now, a single star is amazing, but a global music scene needs a system to function. And this is, in our analogy, MLOps or machine learning operations. Think of MLOps as a publishing company that takes care of all the bureaucracy, like record labels, royalties, promoters, the contracts with the streaming platforms, and so on. So essentially, it's the system that manages everything. And finally, the ultimate goal. You heard a lot, I bet you guys heard a lot about AGI. AGI stands for Artificial General Intelligence. So this is the mythical composer who can instantly master all genres all at once. It's the holy grail of AI research. But it's crucial to know that we are not there yet. And I don't think we'll be anytime soon, but that's a conversation for another time. So, what are the takeaways for this? We need to balance hype versus reality. First, an LLM, our composer in this analogy, it's brilliant at recombining all the music it has ever heard in new ways, but it cannot invent like completely new musical theory from scratch. True AGI, true artificial general intelligence, will require a fundamental breakthrough, not just a more trained composer. We know that technology has always been a moving target. New ideas come and go, new ideas are continually promoted to be the next great thing. However, the landscape is also littered with great ideas that over time did not prove to be very great at all. And we, as technologists, it is good to keep this in mind. So that's why we need to experiment with all of these tools. So, in my opinion, AI does not replace the programmer. It promotes them to a conductor. Of course, repetitive, low-value work, this will be automated. The more, the better. But the real value here will be in the programmer who knows how to guide the tool, how to reject errors, how to orchestrate the creation of complex, robust music, in our case, software. And without the guidance of an experienced programmer or an experienced conductor, our composer, what is going to do? Like it will generate codes with errors, repeats the same mistakes, and cannot create complex software autonomously yet. So skilled human interaction is and will continue to be, in my opinion, indispensable. So some inconvenient truths. LLMs, they do not think, they just predict one token at a time. It's like an LLM is as good as an information retriever. Beyond what some people out there call a glorified text completer, it means that it is only capable of completing with information it has already seen training, and of course with random combinations that sometimes make it seem like new information, but it's not. Also, machine learning models, they do not predict the future. They just find patterns in the past, and trained models work because we know how to make them work. Every stage, training, inference, optimization, alignment, deployment, blah, blah, blah. It's all documented, and we know or must know if we're working with that exactly how all of it functions. And when preparing for this talk, I got with this thinking, and I thought, I have to tweet this. It's like OpenAI, Anthropic, and others are all in the same business. They are just selling tokens. It's like for a monthly subscription fee, you have X amount of tokens to spend. That's it. And the fourth picture here on this slide is a report from McKinsey that says that a massive chunk of AI investment is going to build something revolutionary? No. 7 trillion raised to scale data centers, to build data centers, to increase the computing power for this new AI application. So nothing revolutionary here. So my advice for all of you, get on the hype train, enjoy the ride, or at least try to. But it's okay. If you don't like the ride, you are free to get off of the next station. And also, don't get lost in the jargon. Think of the musician story, of the musician analogy that we use on this talk, and ask yourself, what kind of song or software would you want a generative composer to write it for you? Thanks.